so learning outcome 19. Defines what we mean by balance forces. So balance forces means forces which have the same size but act in opposite directions. And basically this means they cancel each other out. So balance forces cancel each other out and have the same effect as no forces acting. In 21 we're going to try and give some examples of that. So these are my fantastic drawings. So this is a book sitting on a desk. Right, and what's happening there, right, is the weight of the book is pulling it down. Right, the earth. Yes, yep. The weight of the book pulls it down, but the desk is pushing it up. So the end result, when you've got these two forces, which have the same size in the opposite direction, is that the book stays still. So the book stays stationary. I'll put that in a different colour. You all happy with the word stationary? Meaning still, yeah. So there's one example of balanced forces. Once again, fantastic art skills here just about to come up. I'll dazzle you. What do you think?
Oh, parachuting.
Yeah. So there's our parachutists. So the weight pulls the parachutist down. Air resistance pushes up. And because these forces are balanced, the parachutist falls with a constant speed. '22 is, first of all, can we state Newton's first law? So Newton's first law states that a stationary object will remain at rest or a moving object will move with a steady speed in the same direction unless the forces acting on it are unbalanced. So basically these things can only change. Right? If you're stationary, you can only start moving if you've got an unbalanced force. If you're moving steady speed in a straight line, that will continue until you apply an unbalanced force. So this is why the book in LO 21, which means Learning Outcome 21 that we've just done, right, stays stationary, and the parachutist falls at steady speed down, so the direction doesn't change either. Okay, so 23. So now if a passenger is in a car going at 30 miles per hour, so let's just clarify that first point that we made. They are also travelling at 30 miles per hour. So if the car crashes or stops suddenly, and they are not wearing a seatbelt, then they have little or no unbalanced force acting on them.
Is that if the car or it the car? What makes more sense, Angus?
Right? By Newton's first law, so they'll continue forward at the same speed.
You said this was going to be small.
Until they hit the dashboard or something like that. A seatbelt, so if we look at the other fact, if they are wearing a seatbelt, provides an unbalanced force to bring them safely to a stop.